Hi there. We continue our video series on Laplace transforms by considering another theorem that is multiplying by t. So we have seen that the Laplace transform of some kind of function t is eventually some function of s. And of course, this is essentially the integral from 0 to infinity of the function multiplied by e to the minus st dt. So once we integrate all of this, we eventually get some function of s. So what we're considering now is taking this function of t and multiplying it by t and finding the Laplace transform of that. So what would be a generic theorem or equation or formula for this kind of scenario? Well, we just use the definition as we had done so in the previous videos. So what we do is we take the integral from 0 to infinity. We have our function of t. We multiply it by t because that's what we want. And of course, we include the rest of the definition, which is the exponent of to the minus st dt. So we have to observe something at this stage. If we consider this, we have our integral from 0 to infinity, and we have our function of t. So if I look at t times e to the power minus st, I can realize that it's the same as taking the derivative with respect to s of e to the minus st dt. And I put a minus in front. So let's just think about this. Let me write this on the side. If I take the derivative of e to the minus st dt, what do I get? The derivative of the exponential function is just the exponential function. And using the chain rule, the derivative of the inside is t, okay? And if I put a minus in front of here, that will cancel the minus of the inside function because it's to the minus st. So the derivative of this exponential function is t times e to the minus st. And that's exactly what we have here. We have t times e to the minus st, which is just the derivative of e to the minus st. So what I'm going to do is just bring out this derivative to the front. And if I do that, then I get minus dds integral of 0 to infinity f of t, and that remains as is, e to the minus st dt. And what is this? This is just our definition of the Laplace transform, as you can see here on the top. So this is just f of s. So this term will just be replaced by the Laplace transform f of s. So I get dds of f of s. So what this means is that if I have a function and I take the Laplace transform of that function, and now if I want to find the Laplace transform of t times that function, all I do is I just take the derivative of that Laplace transform. So let's just illustrate this with a simple example. So let's just say we have f of t is equal to sine 2t. So using our standard transforms, which you can go and look at in the previous videos, the Laplace transform of sine 2t is just equal to 2 over s squared plus 4. Okay, so just a reminder here that the Laplace transform of sine 80 is just equal to a over s squared plus a squared. So in this instance here, a is 2, and then that's how we get this here. So we had derived this in the first video in this series. So now if I wanted to find the Laplace transform of not sine 2t, but sine 2t multiplied by t, then according to what I just derived here, I just need to take the derivative of this. So this is my f of s. Just erase that. So this is my f of s, my some function of s, which is the Laplace transform of sine 2t. So to find the derivative of t times sine 2t, I just take the derivative of f of s. So minus dds of f of s, like that. So the derivative of 2 over s squared plus 4, okay, so we have to use the chain rule here. So we have firstly s squared plus 4, that's to the minus 1. So let's just write it on the side. So we have 2 into s squared plus 4 to the minus 1. So I bring the minus 1 to the front, so I have minus 2 into s squared plus 4 to the minus 2. But I also have to take the derivative of the inside function. So I'm going to have now this minus 2 that's here, and also need to multiply it now by 2s. That's an s, because that's the derivative of s squared. So 2 times 2 is 4, okay? So I'm going to have minus 4. So the minus here and the minus here is going to give me a plus. So I'm left with 4s, because of this 2 times 2, over s squared plus 4 squared. Remember, it's to the minus 2. So that's the Laplace transform of c times sine 2t. So all we need to do is just find the Laplace transform of sine 2t and just find the derivative of that with respect to s. So thank you very much for watching.